Hi, welcome and thanks for joining me today. Today we're going to continue our discussion on talking about factoring quadratics, and today, more specifically, we're going to talk about factoring special quadratics. So really, special quadratics are just a particular type of quadratic that follow a particular pattern. So once you see this pattern and you can recognize this pattern, factoring these become very easy. So there are two types of special quadratics. There's the perfect square trinomial quadratic, and there is also the difference of two squares. We're going to start out talking about the perfect square trinomial. So in order to kind of lead up to that, what I want you to think about is if we take a plus b times a plus b, so just a generic a and b value in there, nothing special. Um, if we FOIL this out, of course, a squared plus ab, the inner would be plus AB, and the last would be plus B squared. So we end up with this. And if we simplify this AB plus AB, we get 2AB in the middle. So we get A squared plus 2AB plus B squared. So we can also, this we could also write, of course, as A plus B quantity squared. Okay, we could also think about A minus B times A minus B. It's going to work out very similarly. A squared minus AB minus another AB plus B squared, because a negative times a negative makes this positive. Sorry about that. I made that mistake. This should be a plus here. Same with here. So A squared plus 2AB plus B squared is equal to A plus B quantity squared, and A squared minus 2AB plus B squared equals A minus B quantity squared. Okay, so let's look at some examples of that now. So for our first example, example 1, factor x squared plus 10x plus 25. So the first thing we have to do is recognize, is this a perfect square trinomial? So if it follows this pattern, a squared plus 2ab plus b squared, notice that the a squared term would have to be x squared, which is this. And the b squared term here, the one at the end, must be this. And when we find what a and b are, we can decide, we can multiply those together and decide if it's a perfect square trinomial. So here, if a squared equals x squared, a must be x. And if b squared equals 25, b must be 5. So we can check 2ab, which is this middle term. 2 times a times b would be 2 times x times 5. And 2 times 5, of course, is 10. 10 times x is 10x. And that is what the middle term is. So this is a perfect square trinomial in this case. So this factors really easily. X squared plus 10x plus 25 factors into x plus 5 times x plus 5. Or we could rewrite it, since both of these terms are the same, we can write it as that term squared. So x plus 5 squared. Okay, here is another example. Example B, x squared minus 12x plus 36. So here it follows this one. A squared minus 2ab plus b squared is a minus b times a minus b. So again, this a squared term would have to be x squared, and our b squared term would have to be 36. So a squared equals x squared, a equals x. If b squared is 36, then b equals 6, and we can once again check. 2 times a times b is 2 times x times 6, which is 12x, which is what this middle term is right here. So x squared minus 12x plus 36 is equal to x minus 6 times x minus 6, or x minus 6 quantity squared. If you want to double check and make sure these actually do work out, you are welcome to FOIL this back out and see if we end up back with what we started. And if it does, and I can guarantee you it will end up back at that, you can verify that we have indeed factored it correctly. And same with this one up here. We can do the same thing there. Okay, so third example here, 4x squared minus 20x plus 25. So again, if we follow that, here is our a squared. A squared would have to be 4x squared, and b squared would have to be 25. So if a squared is 4x squared, that means a is just 2x this time. And if b squared is 25, b would have to be 5. So we can check and make sure that when we multiply 2ab, we get negative 20x. 2ab is equal to 2 times 2x, which is a, times 5, which is b. Close the parentheses there. So that is equal to, times 2 is 4, times 5 is 20. So we get 20x, which is what that was right there. So this factors into 2x minus 5 times 2x minus 5, or we can rewrite it as 2x minus 5 quantity squared. Okay, so hopefully you're okay with that. Those examples so far. Next ones are difference of two squares. So again, we're just looking at particular quadratics that follow a particular pattern. And once again, these follow a particular pattern as well. So if you think about a plus b times a minus b, if we were to multiply that out, a squared minus ab plus ab minus b squared. So if we FOIL, that's what we get. And notice negative ab plus ab cancels out. And so you end up with a squared minus b squared. So it's the difference of two perfect squares. So a squared minus b squared can be factored into a plus b times a minus b. If you just follow that pattern, it will work each time. So example 2a, factor x squared x squared minus 4. So if x squared minus 4 follows this pattern of a squared minus b squared, that means a squared would have to be x squared, and b squared would have to be 4. So if a squared is x squared, a is equal to x, and if b squared is 4, that means b is equal to 2. Okay, so therefore, x squared minus 4 is equal to the quantity x plus 2 times x minus 2. Okay, in the next example, I'm going to go back and just show you that if we used how we've been factoring like normally, this still works out. So if we have x squared minus 49, notice there's no x term here. So basically that means there's 0x in the middle there. So it's x squared plus 0x minus 49. So what you might have to think about are, what are two factors of negative 49 that add up to 0? Well, for them to add up to 0, they have to be two numbers that are the same, that are just opposite of each other. So for example, negative 7 times positive 7 is negative 49. Negative 7 plus 7 is equal to 0. So this would factor then into x plus 7 times x minus 7. So x squared minus 49 is equal to x plus 7 times x minus 7. Okay, we'll do one last example here. Factor 64x squared minus 169. So again, a squared minus b squared is this 64x squared minus 169. So here's a squared, here is b squared. A squared is 64x squared, so a must be 8x. And b squared is 169, so b must be 13. If you're not sure, just take the square root of 169, and it should be 13. The square root of 64 is 8. The square root of x squared is x. So that's kind of the easy way to find those, is just take the square root. So we end up with 64x squared minus 169 factors into a plus b, 8x plus 13, times 8x 8x minus 13. All right, so there we go. That's all I have for you today. I hope this is helpful for you, and I hope to see you again soon.